right. So, today we're going to evaluate and graph polynomial functions. Don't freak out. I'm not even going to pass out graph paper. Okay? Yeah. So, but I shouldn't say graph. We're going to sketch. We'll sketch polynomial functions today. But the big one on this slide is for Friday. Okay. So Friday we're going to have it's going to be a twofer kind of a day. The first part of the day we're going to have representatives from NTC come into class and get you guys registered for the dual credit option. So if you have an NTC ID, meaning you've taken a dual credit class before. I know MedTerm, I think, is a dual credit class. Remember, not personal financial management, but there's another. Advanced marketing is one. GraphCom, there's a couple of others.
Pre-calc.
Yeah, pre-calc was, but we're signing up on Friday too. So if you've taken one of those classes before and have your NTC ID, you're good. You're golden. Okay? If you haven't taken one of those classes before, and this is your first dual credit class, you need to bring along your Social Security number on Friday. Okay? I'm not going to look at it. They're not going to look at it. You're going to type it in. Okay? But you need to have it because you need to get registered as a student at NTC in order to get their dual credit. And that's the one thing that they need because that's the one identification unique to you. Okay? So that's what they go on. So if you haven't gotten a registered yet, bring that on Friday. Okay? Right? And the registration for this, because we bring them in, they walk it through, they give a little spiel. They've been great. They'll bring you a free T-shirt, all this stuff. They'll probably have some pens. They'll have some extra swag and stuff for everybody, and they're great. They'll get you through it. We'll get through it probably in a month. Probably won't take a month to do that. And then the second half on Friday, we're gonna take a quiz. Okay, so we got that going. Okay, any questions on that? I will say that this dual credit program is pretty awesome. Okay? Right? I mean, just by you get a 70% in this class at Wausau West, they're going to give you free of charge 3 credits. Now, you may be saying to yourself, I'm not going with that. You don't have to go with that. You can go at any. If you go to a state school, for sure it transfers. If you go to a private college or university, 98% of the time it's going to transfer. Right? And it's 3 credits. It's 3 free credits, which rising cost of college education, here, it's about a $500 to $600 value. So it's a good incentive. And at the end of the year, you'll have the final decision on whether or not you take the credit. I won't make that decision. You get to make that decision, okay? Whether or not I submit your grade. You'll tell me, you'll sign off on it, and then so that if you choose not to take it, that's fine. Okay? If you choose to take it, you bet. Lots of people over the past, I've been doing this probably for a decade or so, between pre-calculus, Algebra 3, and we used to have intermediate algebra, but now we have away from it. We've had tons of people with credits. We've had probably close to, I would say I'm averaging probably at least 30 to 35 people a year that get 3 credits. So, super good deal. Yep. All right. So we're in our notebooks today. It's going to be 3-2. So we're going to talk a little bit about a polynomial and what a polynomial is and
what a polynomial can do for us and what the graph of a polynomial is like, what the end behavior, that's the kicker. The big part today is going to be what the end behavior of a polynomial is doing. Okay, right? So it's all that fun stuff. So let's start with what a polynomial actually is. Okay? A polynomial is an expression typically we only have one variable. Okay. We can't solve a polynomial. Okay. Why can't we solve a polynomial? What's missing? Equal sign. Okay. It doesn't have an equal sign, so we can't solve it. What can we do with it, though?
Simplify it.
We can simplify it, like meaning we can.
Simplify it.
It was kind of a loaded question, okay? Because it actually leads to the next one. What we can do is we can put it in what's called standard form. Okay? Standard form of a polynomial has the biggest exponent first. So we start with the term with the biggest exponent. That's going to be our leading term, our first term. Okay? And then we go to the next biggest exponent, and the next biggest exponent, and the next biggest exponent, all the way down to the term without a variable comes last. Okay? So that example that I have written there, that example is written in standard form. Okay? And we said we can only, actually let me go up here. A polynomial function, okay? Now we've got a polynomial function written in function form. This is now an equation. Typically in one variable. Okay? What can we do with an equation? Now this we can solve. Yep. On top of that, we can also graph a polynomial function. Can't really graph just a polynomial because there's no equal sign. There's nothing to set it equal to, so we can't graph it. And we can just simplify it. That's it. Okay? We talked a little bit about standard form here. this, what's below this is standard form again, but I'm gonna actually jump back up here, and I'm going to say when you have it in standard form, the number, actually no, hold on, I don't like number there. I like the coefficient. Oops, that didn't erase so well. The coefficient I spell coefficient. Is there two I's in coefficient? Yeah. What's coefficient again in math? What does that word mean? Big word. I had to check to see how it was actually spelled. What does it mean? Coefficient? Oh yeah? Coefficient? Come on, you guys know this. I know you do. I know you do. But yeah, Carter. Well, take a guess. Can you tell me? Number where? Where? Like, what do you mean next to? So above, below, right side, left side, front, back,
Middle.
top, bottom, middle. Where is it? It's a number, yes. It's attached to a variable, but where is it attached to the variable? It's in front of the variable. Coefficient is a number in front of a variable. Okay? If you don't know that, which everybody but one person didn't know that, you should write that down. Okay? Right? Because then maybe some of you will actually write something down so that when we get to this, stuff later on when we're using this stuff, like, oh, wait, well, listen to what we're talking about. Oh, I can just look back in my notes. Okay? So it's the coefficient in front. Actually, I shouldn't say in front because that's right in there in Word. The coefficient of the first term has a special name. We call it the lead coefficient. Okay? So the coefficient, when we write it in standard form, any of this stuff, more than just that. Okay, that's a good point. So the number that comes first in standard form, we call that the lead coefficient. That's going to come into play in a little bit. So we got to know what that is. Okay? So we already talked about standard form. So let's do this one. We want to reorganize this polynomial function, and we need to put it in standard form. So we're going to start with f of x. By the way, that is how that is said. It's not fx, it's not f, it's f of x. What that tells somebody is it tells you the f part is the name of the function. The x part is the variable in that function. Okay? So if you say f of t, all of your variables had better be t's. Okay? If you say q of r, all of your variables had better be r's, and your function's name is q. Okay? What is the first term in standard form?
Negative 5x by the power of 4.
Negative 5x to the fourth power? Is that the biggest exponent? That one comes first. So negative 5x to the fourth comes first. What do you got next? What's next? You scratched the back of your head at the wrong time. What's up? Positive or negative? Positive. Yep. Plus 2x cubed. Yep. All of those all of those signs in front come along with. Next term,
Negative x squared.
negative x squared, and our last term, plus 4. Okay? So that is our function written in standard form. Okay? Now, one thing that we didn't talk about yet, that we should really go back up here and we should talk about in terms of a polynomial, is something called the degree. The degree of the polynomial is the biggest exponent. Now the degree is nice. Okay? It tells us a few things. The first thing that it tells us is it tells us the number of solutions. If we were solving a polynomial function, the degree is going to tell us how many answers we need to get. Okay? So in this polynomial function right here, f of x equals 6x cubed plus x squared plus 2x minus 5, if I said solve it, how many answers would I be looking for? In this one right here. In this one right here. How many answers would I be looking for? 3, because 3 is the biggest exponent. So if you don't give me 3 answers for this one, you're not done yet. That's one of the nice things about the degree. The other thing that's nice about the degree is it's going to give us insight to what the picture, the graph, if you will, looks like. Okay? It's going to help us, and we're going to be disco dancing here later on. We're going to be disco dancing later on. Okay? So now let's fast forward, or come back to live TV, if you will. What is the lead coefficient for this polynomial function? -5. It's the very first number. Okay? The lead coefficient is the very first number if it's written in standard form. What is the degree of this polynomial? 4. Because it's the biggest exponent. Okay? Lead coefficient is the coefficient on the degree term. So we're looking for that term, that one term right here, this -5x to the 4th, controls the whole kit and caboodle. All that other stuff that comes after it is all fluff. Okay? Main thing today is that lead coefficient and that degree. All right. Let's talk about degrees and types of polynomial functions and what they look like and all that fun stuff. So we're going to make kind of here a little mini chart going on. Okay. Let's see what we got. 1 and 2 and 3 and 4 and 5 and 6. There's going to be six of them. Okay. All right. So our first polynomial function is something called a constant function. Okay? It's just the function equals some number. Doesn't matter what number it is, equals some number. That's called a constant function. I know, I'm the meanest teacher ever. I want you to be successful in this class. Could you? Man. Makes me just want to stomp. Okay? What does a constant function look like? Anybody got any guesses? What kind of straight line? It is a straight line, but it's what?
It's a horizontal line. Yep. A constant function is going to always be a horizontal. That's not a very good horizontal line. Constant function is going to always be a horizontal line because that value of that function is always the same. Okay? Next one that we have is a linear function. Okay? A linear function has a degree of 1 because we have an exponent of 1 on our variable. Okay? Most of the time, you don't see that written, you just see it as that. Okay? What shape is a linear function? Going to be a line, right? But it's not going to be horizontal. It's not going to be vertical. Does anybody remember what we call those non-horizontal, non-vertical lines? I said it one time. I don't expect you to remember it. Well, diagonal would work in this case. In the math world, we call those skew lines. Okay? So they're not vertical. They're not horizontal. They're skewed. Okay? Drop it again. Next one, we have a degree of 2. Anybody know what we call those? A degree of 2? You saw them a lot last year. Not exponential. That would be the variables in the exponent. You saw them a lot last year. What do you got, Mia? Parabola? Yep, that's the shape, but do we remember what we call those kind of functions? Those are quadratic functions. Quadratic functions have an exponent of 2, and as Mia said, their picture is a parabola. Either an upward opening parabola or a downward opening parabola. So it either looks like a U or a hump on a canvas. Degree of 3. Anybody know what we call a degree of 3 function? What? No, now we're not to the W yet. No, we're not to Wausau West's favorite function.
Reverse N.
The reverse n. I've never heard it called the reverse n. It's called a cubic function. It's got a degree of 3. And it looks like it's got a little, it starts either down and then it's got a little bit of a, kind of a like curly Q in it, like a roller coaster type thing. Mm-hmm. Oh, we're getting there. Yeah. Next one, Rick. Next one, Wausau West's favorite one. And it looks like the next one. It's called a quartic. And it looks like a W. Mosinee also likes the quartic. They like negative quartic ones. Let's make up one. Let's make up a quintic one. Yeah, that's the actual name for it. So I need the 5th. Give me a number.
7.
7. Another number.
3.
Another number. 10. So there's my degree then would be 5, and it's a quintic. Don't ask me BFD why I know it's called a quintic. but it looks like it's got 2 roller coasters in it. Yeah. Yeah. Okay? So what we're going to talk about now is we're going to talk about something called end behavior. Okay? End behavior is what your function is doing at x equals positive infinity and x equals negative infinity. Okay? So basically, what it's doing is we're looking at what your function is doing on the right. That's when x is going to positive infinity. And what it's doing on the left. That's when x is going to negative infinity. Okay? So we're talking about what's happening with our function on either side of our graph, on the left side of our graph or on the right side of our graph. Okay? I know. So for these next ones, now I'm going to show you graphs of functions. You can just make a sketch of these functions in your notes. Doesn't have to be exact, okay? But you're looking at the blue functions here now, okay? All right, so here we go. End behavior is of a specific form, and you look at 2 things, and only 2 things, to determine your end behavior. Okay? So the first thing that you are going to look at is you are going to look at the degree. If the degree of your polynomial is odd, your function is going to go in opposite directions on opposite sides of your graph. Okay? So it's either going to look like this, or it's going to look like that. Okay? If your degree is even, your function is going to go in the same direction on both sides of your graph. Okay? Now, the second thing you're going to look at is you're going to look at the positivity of your lead coefficient. That tells you what's happening on the right side of your graph. Okay? So if your lead coefficient is positive, your right side is going up. If your lead coefficient is negative, your right side is going down. And then the left side is going to, if it's odd, it's going to go up. If it's even, it's also going to go down. You know what I mean? So the left side then goes off of the degree. Okay? So the form that you have for end behavior is always going to be this. As x goes to positive infinity, your function goes to. So this is saying, as x is going to positive infinity, is saying x is getting bigger and bigger and bigger. That's my right side. So on the right side of my graph, as x is going to positive infinity, what's happening with my function? It's going up and up and up and up, and it's never stopping. So my function is going to positive infinity.
where you're going to make a big mistake and where you're going to get points taken off is you're going to get these, because I've seen it the last few years, you put these in the wrong order. This order is non-negotiable. You're talking about what X is doing, and then because X is your inputs, and then you're talking about what happens to the Y's after that, because Y's are your output. Okay? So as X goes to positive infinity, my function is going up, so my function is going to positive infinity. As X goes to negative infinity, that's the left side of my graph, my function is going which way?
Left.
Down. No matter.
Down.
I'm going left, my function is going down. Okay? So that's going to negative infinity. Okay? As X goes to positive infinity, on graph number 2, which way is my function going? Up or down? Going down, right? So that would be going to negative infinity. As I look to the left side of my graph, as X is approaching negative infinity, which way is my function going? Up. So that's going to positive infinity. Now, right now, we're giving you the pictures of the graph. Tonight, or on your homework that you got on Monday, we just gave you the function. That's all you need. We don't need to see the picture, okay? Because we know that the degree is going to tell us if it's going the same direction or opposite direction, and the lead coefficient is going to tell us what the right side is of our graph is doing. Okay? On even functions with a positive lead coefficient, both of them would be going to positive infinity. Because they have to go in the same direction. If we have a negative coefficient and an even degree, both of them would be going to negative infinity. Okay? Now, if you only write down one thing, you should write down this slide. And everything that I put on this slide, you should write down. Okay? Because this is summarizing everything that we just talked about. Okay? So you need to, when you're graphing stuff, when you're graphing stuff, or I shouldn't say when you're graphing, when you're finding end behavior of functions, you need to ask yourself 2 questions. The first question that you're going to ask is the highest power, okay, we call that, remember, the degree, is the degree of my function odd or even? Because if it's odd, the sides go in opposite directions. If it's even, the sides go in the same direction. Second question you need to ask yourself is the lead coefficient positive or negative?
because that's going to tell you the right side goes up if it's positive, and it's going to tell you that the right side goes down if it's negative. As x goes to positive infinity, that means we are talking the right side of our graph, or the right side of our function, or as our function has increasing inputs. I said input, almost said inputs. Increasing inputs. As x goes to negative infinity, means we are talking about the left side of our graph. As our inputs get smaller and smaller and smaller and smaller. Okay? So let's try one together here. So here is our function. Okay? 1, I want us to write it in standard form. 2, I want us to give a sketch of this function. And 3, I want the end behaviors written out of this function. Okay? Standard form is going to start f of x equals first term, anyone. Negative 2x to the 7th power. Do we all agree with negative 2x to the 7th power? Okay. Next term after negative 2x to the 7th power. Negative 15x to the 4th. I would agree with that. Next term.
Plus 3x cubed.
Plus 3x cubed. I would agree with that. Next term. Negative x. Last term. Minus 12. Do we all agree that that is the standard form of this function? Okay. Question number 1, now to make the sketch to help us with end behavior. Question number 1 is biggest exponent, the degree, is odd or even?
Odd.
It's odd. So does that mean that my function is going the same direction or opposite direction?
Opposite.
Okay, so that means we're going in opposite directions because it's odd. Second question you have to ask, lead coefficient. What is the lead coefficient? Negative 2. So that tells me that the right side of my graph is going down. Okay? So if they're going in opposite directions, my right side would go down, my left side would go up. So it's going to have 6 humps-ish, or so it's going to look something like that. Again, not looking for an exact picture here, just looking for a sketch. Okay?
one of my end behaviors would be what? As x goes to negative infinity. Oops, I forgot to ask. So what are we talking about here, Carter, when you say as x goes to negative infinity? Things like it, left side. So left side of my graph is my function going up or down?
Down.
Left side of my graph. Going up, right? Okay. So then that would be f of x goes to positive infinity. That's one of my end behaviors. What's the other one?
As x goes to positive.
As x goes to positive infinity, now we're talking the right side. What is my function doing? Going to negative infinity because it is going down. Okay. So on your homework for this week, okay, on the front side of your homework, it says that you need to simplify each function, which means write it in standard form. That's part A. Part B then says you need to state the end behavior for each of those 6 functions. Okay? You can do all of that. As of right now. If you wanted to try the other parts of your homework that have adding and subtracting and multiplying of polynomials, you can try that, but that is going to be our review for tomorrow as to what we're going to do. Holy cow, almost 43 minutes.